Dear students and participants of the course on railway engineering, now today we are going to discuss about the creep in rails. In the previous lecture, we discussed about the short welded rails, and there we have talked about the various components in terms of the sleepers and the ballast which needs to be used along with the rail sections, how the SWRs are laid, what are the various gap surveys which needs to be done, what type of maintenance activities are required, and then at the same time the do's and don'ts which needs to be taken care of by the staff of Indian Railways when they are inspecting the short welded rails. Today we are going to discuss about the creep in rails. This is one of the aspects which surfaced when we were talking about SWR. Now what we are going to discuss is the effect of creep, the reasons why this creep occurs, what are the theories behind the occurrence of the creeps in the rail sections. That means we are talking about the track, overall track here, how we can identify and how we can measure the creep in those rails, and what can be the methods to reduce the creep. So these are the points which we will be taking up one by one. So let us talk about the creep. What is creep? Creep is the longitudinal movement of rails in a track with respect to the sleepers. So we have the sleepers, and at the top of the sleepers the rail sections have been placed, and though these sleepers and the rail sections they have been jointed together by way of fastenings, if any such longitudinal movement happens which can be in this direction or which can be in this direction depending on what type of a cause is there at that point at that particular place. So the movement when it happens, that is what we are talking. So here the sleeper remains in position, so it is here only, it is here only. But if we talk about, say, if we mark some point here or if we mark some point here, and when the creep is taking place in the direction towards right, you may find that after some time this mark has moved to some other location, and that is an indication that a creep has occurred in this particular track. Usually it is a slow movement in the direction of the dominant traffic, because if the dominant traffic in this direction, obviously this track is being used for the both directional movement, but major traffic goes in this direction and lesser traffic comes in the other one, then the creep is going to be created in the direction of the major traffic. And this creep, it has been observed that it is location specific. It may happen that in this section of the track it is happening, but if I go beyond here, then there is no creep which is occurring. So it has occurred only in this particular site. So there is no creep. There is no case where you find out that there is a shift of some markings. And it also varies in magnitude. It varies in magnitude with respect to the location, with respect to the type of reasons which can be there. Sometimes we find it is going very fast, sometimes it may find it is very slow. So not exactly you can say that every time in a uniform pattern this is going to happen, because there are n number of factors which are making this to happen. Now what are the indicators? Now when we say the rail is moving, so rail section is moving in one direction in this form, in this particular direction, and say this is the rail end, what will happen? It will come to say in this particular position, and by this position there has been another rail section. So this gap which is provided has reduced, or in some of the cases it may even happen that gap has closed, there is a jam condition of the joint. So closing of joint in the direction of the creep is one of that indicator. Another thing which can happen is that you can find out at the other side of this particular rail, if it is happening to this specific rail at this location only, then the gap which was previously there in this form at this position, because this rail has moved in the right hand direction. So, the new position of this rail will be like this. So, it means initially the gap was this much, now the gap has become this. So, there is an opening of the gap. So, this is opening and this is a closing of the gap. Then another one which can give you an indication, which I discussed here, that there is a clip which is holding the rail in position on the sleeper. So, if there is a movement, now this clip will try to hold the rail in position, but the rail is moving, and because of that reason there will be a scratch marking. So, when there is a scratch marking on the rail flange or the web due to the type of fastenings which is being used, say here one type of fastening which is being talked is a spike head, and that is also an indication that in this particular track at this location the creep is occurring. What are the effects? 2 or 3 effects we already discussed about. We said there can be a possibility of opening of the joint, or there is a possibility of that jamming of the joint. It comes close and there is no space left, no gap left. And another thing which may happen when we are talking in plan, that this is the rail section with the gap being provided, and now this rail section is moving in this direction, and this is the one which has a creep, but there is no creep in the other rail section. It will touch the rail section, and still if the creep is going on, then the section of this rail will go a bit out in order in this form, because there is no other way than this creep can be sustained. So, there is a kink formation at this point. So, if you look in the form of a track, then what you found is that the track goes in this way. So, a kink has occurred. Then sleepers, they get out of the position, and when those sleepers get out of the position, because here we are providing a sleeper in this form, say here also say a sleeper is being provided. So, if the things are moving outwards, then the sleeper is also move in the outward direction. So, it is not in position. When it is not in position, then the gauge which is being maintained here in terms of G, that is also going to be affected. So, there is always a possibility that the gauge may change a bit. Or if you look in the direction where we said that this is a profile, so the alignment has shifted now. It is not with respect to the center line which otherwise has been fixed there. So, there is a change in the alignment, there can be change in the gauge in terms of some movement, and that is where the sleepers are also getting out of the position. There is a possibility of the buckling of the track, and that can cause the derailment of the train. If the buckling is happening not in one direction, it happens that this side of a rail goes in this way. Then here the total gap has increased. It is not G, it is not 1676 in the case of broad gauge. If it is increasing, that at this point, because it has widened, there is always a possibility of the derailment. The points, crossings, switches, interlocking, everything will get distorted because of the creep in the rail sections. So, this is also a problem here. We need to take care of it. And forging of the ballast will also be there. So, you will find that because of those shiftings there are accumulations. So, at one point there is an accumulation, other point it is a deficiency. Smashing of the fish plates and the bolts which are connecting the two rails, because there is a lateral movement, there is a longitudinal movement. So, because of that longitudinal movement, now the stresses will be there in these bolts and the fish plates, and there is a possibility that these fish plates and bolts they get smashed. That means now they are going towards the fracture side, they are going towards the total fatigued condition side. They may crack, or the cracks may appear in that also. Then removal, replacement, maintenance, they all become difficult, because now if you are going for a mechanized maintenance, then they are being set with respect to the one alignment, one gauge, and that will not be available at a location, and that will create a problem in terms of those maintenance activities. There is also a possibility of the bending of bars which may happen because of the creep in rails. So, there are many such things which are possible, which can happen, and we have to take care of. This creep in rail should be as far as possible reduced or eliminated. Now, which are the tracks which are susceptible to the creep? The steel sleeper tracks or CST9 sleeper tracks, when they meet the wooden sleeper tracks, there is a combination now. In one of the track we have used wooden sleepers, another one you have used CST9 sleepers, then that is the location where there is a possibility of the creeps occurring. If there is a dip in the stretches having long gradients, so you are going in the long gradient condition, but then there is a dip. So, you are coming in this form and this form, so there is a dip or here. So, at such type of locations, then also there is a possibility that the creep may take place. Then approaches to the major girder bridges or other stable structures. So, you have the bridge is going to remain as such, but when you are talking about its approaches, it has been observed that on those approaches the creeps are possible. Similarly, in the case of approaches to the level crossings and points and crossings, these creeps have been observed to be more. Now, what may be the reason that why on the approaches to the major bridges, why to the approaches of the level crossings and points and crossings this is happening is related also with the speed of movement and the speed with which the train is going to traverse on the bridge or on the points and crossings or on the level crossings, and if there is a sudden change in those particular speeds with which it is approaching, with which it is negotiating that or traversing that location, then the creep is a possibility. Then ironing out effect of the moving wheel on the wave formed in the rail. We discussed about the wave formation, and the case of wave formation, we said that if the track is being provided and there is a wheel which is moving at the top of it with some load and going in this direction, then because of this load there is deformation, and this deformation is being carried forward in terms of a wave. So, there is a forward rail is having a wave formation, and because of this, as this wave continues, so this wheel will take this wave forward, and that is also a possibility that the creep will occur in this if not the fastenings at the bottom of the rail sections are not working in a right manner. Then there is a tendency of the wheels to push the rail forward and backward during acceleration or deacceleration or even during running. So, when a train accelerates, then it will be pushing the rail. Now, there is a possibility the rail is being pushed backwards or the rail is pushed forward. If the brakes are being applied, so the force gets in this form and it tries to stop. So, it is going to push in this way. The rail forward or backward movements are possible. Impact of the wheel on the running end of the rail, particularly at times when the rail is in the state of expansion and contraction, that is also one time when the creep can occur. So, that is what it is talking about is a joint here and the wheel coming at the joint and still moving, but putting the pressure at the rail joint. And at that time there is also another thing which is happening is delta T, the change, the variation in the rail temperature, and because of that there is a possibility of the expansion or a contraction. So, if these two things are coming together, then it has been observed that these also causes the creep in the rail section. Now, these particular things which we have discussed, where there is an acceleration, there is a deacceleration, there is a effect of starting of a locomotive or a train, or there is a condition where the brakes have been applied or it hits on the rail end, all of these things which we talked, they basically give rise to the different types of the creep theories which we are going to discuss further. But still before that, The other possible causes which can be there is like starting, accelerating, slowing or stopping of the wheels. When there is a starting or acceleration, then there is a backward thrust which is created. When there is a slowing or deacceleration, it causes the push in the rail in the forward direction. So, these changes are there, there is an acceleration, deacceleration, accordingly there is a backward push or the push in the forward direction. There can be a thermal expansion or a contraction of the rail because of the change in the temperature, and it is nothing but it is basically generated from the surroundings, and those surroundings will define what is the range of temperature in which it is changing, positive and negative side with respect to the mean rail temperature, and then what is the location effect. Whether it is say in a desert area, more of sunshine is there, there is more of temperature rise is possible. If it is a humid area, then the temperature may not be rising that much, but the effect of humidity will be there. So, you need to see that what type of a location is there, and that is also going to influence the change in the temperature and the range of that temperature change. Unbalanced traffic, we just started with this. There is a heavy traffic which is moving in one direction, say it is a freight corridor. In the case of freight corridor, the freight is being carried from A to B, but when we talk about the back movement, so this is an empty movement. It means in the case of starting, in the case of acceleration, in the case of stopping, in the case of any such sort of an interaction of the wheel with the rail, when it is going from A to B, it is completely full, then those type of impacts on the rail sections will be more as compared to when it is coming back. It means if there is a creep at all in this particular track, then that is going to be from A to B direction. It will also get induced because the design of the track is not right, it is not done in the correct manner. Then effect of the curve and gradient. We are coming on this gradient, the wheel is coming and say we are coming down. So, when it is coming down and it is a steep gradient, then there is a braking motion which will be used again and again by the locomotive so as to control the speed of the train when it is coming down. Whereas, when it is going up, the locomotive has to put more effort, more pull or pressure in that form, and that is where that will also create creep in this particular track. Poor maintenance. The poor maintenance of the track in terms of the rail, whether the rail is quite old, and therefore there is a possibility that the various types of dimensions which have been given for different locations, they have gone out of the permissible limits, and that is where the creep gets induced. If it is new, then the possibility is that it is lesser in terms of the magnitude. Similarly, for the light and the heavy rails, the values are going to be different even if the same light or heavy has been used at the same location. So, that is the difference which may come. Then condition of fastenings and joints, how good they are, whether they have been able to put the load which is required to be put, they have not got loosened out. What is the quality of the joint in terms of its connection between rail and rail, then those things are also going to define whether there is going to be a creep, or if it is a creep, what is the magnitude of that creep. And the condition of ballast cushion and formation is the another thing. Now, avoidable causes which can be there, what we can do is the tow load is one important aspect which is looked at when a rail is being connected to the sleeper. So, it is coming through the fastening, whatever fastening is being used. So, it may happen that a fastening is being used in this form, and that is coming at the top of the rail section here. So, there is a clip which can come like this, and it is coming on the at the base is the sleeper. So, if this inadequate tow load is being applied. So, there is a tow load here. If this is inadequate in nature, then it means the connection is not properly secured and it allows the movement, but if we have secured this properly, then that can be avoided. Inadequate ballast resistance to the movement of the sleepers due to poor or insufficient ballast. So, it means if the maintenance has not been done in a right manner, we have not removed the deficiencies of the ballast, then we are ourselves inducing the creep in that particular track. So, if we can do good maintenance and that good maintenance removes the inadequacy in the ballast section, it is fine. Ineffectively or badly maintained rail joints, again it comes to the maintenance, and we talked about do's and don'ts when we were talking about the SWR. So, that is an important aspect. When the visual inspection is being done by the gang, then they should find out which particular rail joints they are jamming, which are opening. Two successive rail joints, they should not get jammed out. So, if they have not been identified, they have not been rectified immediately, then we are going to induce the creep by ourselves in those particular tracks. Light rails versus the traffic load. The traffic load is high, but we are using a lighter rail section. Then the stresses which are going to be induced because of the movement of the wheels and the locomotives at the top of the rail sections and the induced effect in terms of starting, accelerating, stopping or braking, all those things that will be heavier in the case of the light rail, and this will also induce the creep. So, therefore, we need to go to the heavier rail sections, and that is where we can either avoid or reduce the creep which can occur in the track. Or improper expansion joints is the or gaps is the another issue. Then decaying sleepers, they should not be there, or uneven spacing of the sleepers, that should also not be used. Lack of proper drainage, we started with this also, that the drainage, the good drainage should be there in the formation level or the components which have been used. So, that will help, because the strength and the stiffness of the track will be maintained if we have taken care of this aspect. Yielding formation resulting in the uneven cross levels will obviously induce the creep. So, if we can avoid this, then there is no issue. Those are uneven packing and the rail seat wear in the metal sleepers, all of these things together are such where there is a possibility that we can do the good maintenance, we can bring back the track to the good quality and we can avoid the creep. Now, what are the theories which are there behind the creep? The wave theory, the percussion theory and the drag theory. Let us talk about the wave theory. What is wave theory has been shown here. We have discussed about it again and again. There is a wheel which is having a load, because of that there is a depression with respect to the rail level. So, this is rail level, and because of that there is a lift at the front and the back of the wheel, and if this wheel is moving in this direction towards the right, then this wave will carried forward. So, this is what it says. So, moving wheel loads, they sets a wave motion in the rails, a vertical reverse curve is formed ahead of the wheels in the rails, and as wheel moves, the lift in the front of the moving load is carried forward, thus causing a creep. So, that is a way, this is the one of the theory behind the creeps which are occurring in the rail tracks. And this wave action, this can be controlled by this lift as well as the pitch. So, pitch and the lift, if we can control these things by way of either the placement of the sleepers, the type of fastenings being used, then we can reduce the creep. And this pitch or the lift, that is related with the track only, the track modulus, the track stiffness and the track stability. So, if these are good, have been maintained, then the possibility of this wave movement will be less, and therefore, it will result in the lesser creep or no creep. So, what are the controls? Use the angular and the heavy ballast, which will give you a better interlocking, which will improve upon the track stability in terms, and which will also improve upon the track modulus. Lesser spacing of the sleepers, so you are strengthening the track at the bottom of the rail by way of providing these. use bigger rail sections, that means you are putting the heavier loads here, and increase the stiffness of the track. So, these are some ways in which the waves here this can be controlled. Another theory is the percussion theory. The percussion theory is more related with the impact at the rail joint. So, here the two rail sections are being shown and they have been jointed by a fish plated and the fish bolt arrangement. Now, wheel comes at the location where the joint is and then it hits the corner of the rail and there is a force R which is being transferred to the rail section. Then what are the conditions in which this can happen? Say the gap is more. As soon as the gap is more, the possibility of the wheel hitting the end will be more, or the diameter of the wheel, this is less. So, smaller diameter wheel is being used, then the possibility of this contact will be higher. And because of that, if this pressure gets exerted, it will be having two components. One is P, which is going in the direction along the rail, another is going downwards. So, this component P will cause creep, that is the longitudinal movement of the rail is going to happen here. So, what it says? It states that the creep is due to the impact of the wheels at the rail and ahead at the joints. At the rail joint, the wheel load presses the trailing rail down, thus causing an impact of wheel with the forward rail. So, here it goes down and then it allows more interaction here, and that is where it is pushing the rail in the forward direction. At a strike, the force in the direction of movement pushes the forward rail ahead, thus causing the creep as we have discussed. The resultant of the vertical load and the forward force cause battering of the rail end. So, if this is a forward force P, this is the vertically downward force Q. If we take this R, then this R will cause the battering of the rail end like this. So, because of this force R. So, what are the reasons which will increase the creep here? Very first thing, if the fish bolts are loose or they are weak, or the fish plates are worn out, or the packings below the rails with the sleepers they are loose, or the joint is wide or it has gone into an expansion conditions, and there are heavy axial loads which are moving at a faster speed. So, heavy axial load means it pushes this down, and when it is moving at a faster speed, then the strike here will be becoming the dynamic load. So, a dynamic load strike will be there, which is a static load multiplied with the speed factor, which we have discussed previously when we talked about the stresses. The third theory is the drag theory. Now, this drag theory relates the motion of locomotive and the wagons, and it is related with the acceleration, deacceleration, starting and stopping of locomotives and wagons. What it says? The driving wheels of the locomotives, they causes the backward thrust. So, when they will cause the backward thrust, then only they are going to move forward. But when this backward thrust is being created, the rails will move backward. Whereas, the other wagons which are at the back of the locomotive, they are trying to not move. There is an inertial effect, and because of that inertial effect, they will like to remain in their position. So, the locomotive wheel is putting the pressure like this so as to move forward. So, this is for loco, and then at the back when the wagons are there, they are trying to stay in their position. So, they are putting the pressure like this, and that means they will be generating something in the backward direction. So, here this is for wagon. So, they both are acting in the opposite directions, but what is being observed, the hauling power is with the locomotive, and therefore, the effect is more on the driving wheels, and that is the reason with respect to that particular movement, the creep will take place in the direction of the movement of that locomotive. So, here say not in the direction of that movement, but rather in the opposite direction, because it is putting it backward. Now, how we can measure it? There is a creep indicator. You can see this, a sleeper is there at the top, the rail is there, and then there is a creep indicator as a rail post being provided on the sides, and there is a string here, and this string is being shown here also. Now this is a plan. So what we found is that a string is here, so it has a marking at this particular location. Now suppose this rail starts moving in this direction, then what will happen is after some time this marking will shift, and that is an indication that the creep is occurring at this point. So this is a creep indicator which is used on the tracks. And it is used at an interval of 1 kilometer in all those locations where they are supposed to have a creep. The top of the post is 25 mm above the rail level. The creep is measured using a fishing cord, which as I said is there, and it is stressed over the chisel mark which is made here. Then the maximum permissible limit of the creep is 150 mm. So that is the total value which can be there. Now what are the preventions? Pulling back the rails. If at any of the location the rail has moved forward, then let us try to pull back to its normal position. And for that we can use the crowbars and hooks which are put in the fish bolts area. So bolts will be taken out, then these will be pushed and we will try to push it back. So it is very slow movement condition, it will take a lot of time and it is very difficult also, but can be done only for those areas where in a small length the creep has occurred. The another way of doing it is the use of the steel sleepers. Steel through sleepers, they are the best in this particular case, or we can increase the number of sleepers, that is the sleeper density M plus X is improved. Or we can use the anti-creep bearing plates, but these anti-creep bearing plates they are used with the wooden sleepers, and nowadays we are not using those wooden sleepers in large numbers. So that becomes a limited option. The joints shall have the canted bearing plates with rail screws so that they remain in position, that is another thing. Another way of doing it is to use the anchors. We did talk about the anti-creepers and anchors. These all black ones, they are basically the anchors which have been provided, and they are provided on the basis of in which particular direction the creep is happening. Say in this particular case, if the creep may happen in any of the direction, then the creepers or these anti-creepers or the anchors, they have been used in all the four sides. But if it is happening say in this direction, then they have been provided here as well as a combination, but on the alternate sleepers, not on each and every sleeper. So there can be 4 anchors per rail if the creep is 7.5 centimeter to 15 centimeter in a month. If it is 22.5 to 25 centimeters in a month, then 6 anchors per rail are used. They can be used at the level crossings, at yards, or any of such location where there is a possibility that the heavy brakes will be applied. But they are never used on the bridges, and they should be able to resist the movement of the rails. That means the design and strength has to be decided on the basis of the force which is going to act, because they are working in similar conditions as a tow load. So they will try to resist the movement. So this is a rather important design aspect here. When these are fastened to the foot of the rail, they should butt against the sleeper, then only the load will be transferred. These are fixed to good quality sleepers. If the wound sleepers are there, they will not be effective, they will not be give you the results. How these can be fixed? There are different ways of doing it. Either you can clamp them, or you can provide a spring grip, or there is a wedging action. Wedging action means a wedge which is of this type is being inserted between the rail and the sleeper, or there is a spring gap. So spring gap is something like this. So it is being provided again with the rails and the sleeper. So these are the different types of systems in which they can be clamped. Adjustment of the creep, adjust the creep before the commencement of the summers. So this needs to be checked here, because in the summer the temperature variations will be more, there is more possibilities of creep. Pull back the rails during the cool hours of the day, not during the time when the temperatures are high. Carefully measure the expansion gaps as existing, that will give you an idea whether it is closing or it is opening. The total amount of gap in the length should be equal to the standard expansion gap required for the temperature at a time multiplied by the number of joints in the length. So, this is again related to the measure. So, you have n number of joints, and in one joint there can be g gap. So, if take a summation of that on I is equals to 1 to n. So, that is the total gap which is possible can be provided. Work should start at the running on end of the length, commonly just beyond the points and crossings or level crossings. Just after that this is started, and when the total gap is more than as stated here in the point number 4, then it is necessary to provide the closure rails. Closure rails means because the gap has increased, now you have to insert some section of the rail there, so that the gap is not more and there is no possibility of the derailment at that point. So, with this we close our discussion. What we discussed was the creep-in rails, their effects, their reasons, the locations where these can appear, the theories behind the occurrence of the creeps, what are the precautions which can be taken, how the creeps can be measured, and finally what are the possible remedial measures and adjustments which can be done so as to contain the creep. Thank you, and we will be meeting in the next lecture.